Assalamu alaikum warahmatullahi wabarakatuh. This is Mr. Abdul Majid, and this is Chemistry IGCSE. First lecture we have is electrolysis. What's meant by electrolysis? Electrolysis is breaking down of ionic compounds using electricity. Ionic compounds should be aqueous or molten. But before we go on, we have to just add some basic rules or some bases to go for any electrolysis. What will form at the anode and what will form at the cathode? Remember that anode is the positive end, positive end. How to memorize it? Remember, usually positive anode. So on the other hand, cathode must be negative end. On the or at the positive end, we attract or we find negatively charged ions, such as hydroxides, such as halides. So what are the two basic rules? The two basic rules is halide is present. What is halide? Halogen or group 7. Easy. Halide is present. Or halide or halogen is absent. Halide is absent. If halide is absent, fortunately, oxygen evolves. If halide is present, we have two pathways. The first pathway is halide is concentrated or dilute. So concentrated or dilute. If the halide is concentrated, so it wins. Halide itself. And if the halide is dilute, so again, fortunately, our good friend oxygen evolves. On the other hand, for the cathode, we have two basic rules. First one and the second one. The first one is metal or positively charged ion is more reactive than hydrogen, more reactive than hydrogen, or of course, to be less reactive than hydrogen. If the metal or if the ion is more reactive than hydrogen, so in this case, our good friend hydrogen wins. So hydrogen here evolves. On the other hand, if the metal or if the ion is less reactive than hydrogen, so the metal wins. For example, if you go for electrolysis of sulfuric acid, dilute sulfuric acid. Dilute sulfuric acid, let me just H2SO4 plus SO4 2 minus. And of course, we have aqueous solution, so we have water as well. We have OH and we have proton. Now, we need to go for anode and cathode. To the anode or positively charged ion, we can attract OH and SO4. And to the cathode or the negatively charged, we can attract, of course, only hydrogen. So here, at the cathode, hydrogen evolves. Remember that here, we don't have hydrogen, so automatically O2 will evolve. Check one question. This question. Now, we need to go for electrolysis of a concentrated aqueous sodium chloride and a molten lead bromide. Remember that in molten state, we don't have HOH. We don't have any aqueous solution. We don't have any water. So in case of having molten lead bromide, we have lead and bromide only. Okay? So what is correct in both experiments? Feel free to pause the video, then come back. Back again, we go for each option one by one. Starting from D, hydrogen would be formed at the cathode in both of them. Is it true or false? Of course, false. Why? Because in case of molten lead bromide, we don't have hydrogen. so D is out. Hydrogen would be formed at the anode. Of course, this is completely wrong because we never find hydrogen at the anode. Now we end up with two options, A or B. A metal would be formed at the cathode in both of them. This is okay for one of them, which is molten lead bromide, but wrong for aqueous sodium chloride. So the option is A. Another one. Which statement is correct for electrolysis? Now we go for each point or each statement and we criticize it. When molten lead bromide is electrolyzed, bromine is formed at the cathode. This is completely wrong. Why? Because bromide or bromine is a halide, halogen. It never goes to the cathode. It goes to the anode. So this is wrong. Since one is wrong, so automatically A is out. B is out, and we have only C or D. From the two options, 4 must be there. Now we go for 2 and 3. When dilute sulfuric acid is electrolyzed, we just briefly done it, oxygen is formed at the anode. I think this is correct option. Now, what's wrong in 3? When concentrated aqueous sodium chloride is electrolyzed, sodium is formed at the cathode. Wrong. Why? Because sodium is more reactive than hydrogen, so hydrogen in this case will win. Last point we have today regarding electrolysis is very easy point, which is electroplating. What is electroplating? Electroplating, in some cases, we have to give some metals or some materials more attractive appearing or to protect them from corrosion, for example. We just design the cell. In this case, we have anode. So this one is a positive, and we have cathode. So this is the negative. And here we have the electrolyte or the solution. So this is a negative, and this is a positive. Here, we need to electroplate, for example, we need to electroplate iron with silver. 3 rules for electroplating. Number 1, the electroplated material to be placed as a cathode. So here we have the iron. On the other hand, the material to electroplate with, material to electroplate with, to be the anode. So in this case, silver to be the anode. So this is condition number 2. And condition number 3, the electrolyte or a solution is a solution or electrolyte of the anode. So 3 conditions for electroplating. Anode is the material to plate with. Cathode is the material to be plated. And the electrolyte or a solution is a solution of the anode. We have 2 questions here. Question number 1 is the object to be electroplated is, feel free to pause the video. Back, material to be electroplated is the cathode, and the other electrode is made from silver, of course. So here, D. غلط 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 غلط.